Hello folks, we are taking the chapter 4 now, Principle of Mathematical Induction, and we are going to take the exercise 4.1. There's only one exercise in this chapter and we are taking now the part 1. In this part 1, we will take the first two problems. Throughout this chapter, we are going to take this principle of mathematical induction. What we do there is, we will give for the given mathematical statement, we will prove that P of 1 is true in the step 1. Then in the step 2, we will prove that P of k plus 1 is true when we assume that P of k is true. And with the help of both these steps, we will assume that this result is true. So it is like by the step 1 and step 2 together, we are showing that this result is true. That's how it goes. When we do the problem exactly, you will come to know what steps we are going to follow over here. The steps are very tailor-made. It's the same step that you have to follow in every problem. So yeah, it's just removing certain things and putting some things, and that's how the problem gets completed. So to start with, let Pn represent the given statement. That means this entire statement we are representing by Pn. Represent the given statement. Then we take step 1 to show that P of 1 is true. Now this is its format. Now what is the meaning of, in a sense, what is the meaning of P of 1 means? In the left hand side, take only the first term, and in the right hand side, wherever n is coming, there you put 1. So you will get 3 raised to 1 minus 1 by 2. So you've got to show this. Now in order to show this, we take the LHS. Consider the LHS. LHS here is 1. Then we consider the RHS. It's 3 raised to 1 minus 1 by 2. So 3 minus 1, 2 by 2. Answer is 1. So you're getting the LHS as 1. You're getting the RHS also as 1. Therefore, LHS is equal to RHS. And that's how you're getting P of 1 is true. Right. Now once that is over, we'll take the step 2. And what do we do in the step 2? We assume that P of k is true. So P of k is true means the result is true for the kth term. So it is 1 plus 3 squared and so on, 3 raised to k minus 1. Wherever n is coming, we are putting k basically, that's all. So it is 3 raised to k minus 1 by 2. Then to show that P of k plus 1 is true. So that means, what do we have to show? We have to show 1 plus 3 squared. What we literally do is, we three k minus 1 and then the next term also, that is 3 raised to k. And here wherever k is coming, they will put k plus 1. Now, consider the LHS. For this, and till here we know the result. We know that it is 3k minus 1 by 2 because we have learned we have assumed the result. So 3k minus 1 by 2 plus 3 raised to k. 3 raised to k. So 3k, 3 raised to k. Right. So let's do the continuation here. What will happen? We'll try to equalize the denominators. Here it is 1 into 2 into 2. So you have 3 raised to k minus 1 plus 2 into 3 raised to k, and you have the denominator equalized to 2 now. So what happens is, we have got these both are like terms. 3 raised to k plus 2 into 3 raised to k is 3 into 3 raised to k. 1 plus 2, 3 minus 1 by 2, or rather you could call it as a raised to m into a raised to n, a raised to m plus n. So this is 3 raised to k plus 1 minus 1 by 2. And that's exactly what we need to show. That's your RHS. Therefore, P of k plus 1 is true. That's what we have shown. So what we have done, therefore, from steps 1 and 2, given statement is true. By PMI, principle of mathematical induction. Certain teachers, they will allow you writing PMI. Certain teachers would ask you to write it in full form. Then in that case, you have to write principle of mathematical induction. Otherwise, PMI is okay for writing the principle of mathematical induction. That is our question number 1. Now we'll quickly move to question number 2. And let's see what we do in the question number 2. We'll just do little alterations and we'll see how it is working. Yeah. We are going to do the question number 2 now. Yes, question number 2 starts like this. Let Pn represent the given mathematical statement to show that P of 1 is true, which means 1 cube is equal to 1 into 1 plus 1 by 2 the whole squared. So LHS is 1 cube 1 and RHS is 1 into 2 by 2 the whole squared. So that is 1 squared, which is 1. So LHS is equal to RHS. That's how you're getting P of 1 is true. Now assume P of k is true. So P of k is true means, as I said, wherever n is coming, you can just put k, you get the answer. Plus k cube is equal to k into k plus 1 by 2 the whole squared. So and then we extend it to k plus 1. So you have to show that 1 cube plus 2 cube and so on, k cube plus the next term k plus 1 the whole cube is equal to the terms here. Wherever k is coming, there you put k plus 1. That's it. So this first term will become k plus 1. Second term will become k plus 2 by 2 whole squared. Now the LHS here is 1 cube plus 2 cube and so on, k cube plus k plus 1 the whole cube. So this much is there with you. So that you can replace. Till k cube you can replace with k into k plus 1 by 2 the whole squared plus k plus 1 the whole cube. So you have k plus 1 the whole squared common. Let's see what comes. K plus 1 the whole squared, you've taken it as common. So what is remaining here? K squared by 4. And what is remaining here? 1 k plus 1 is remaining because you have taken square out. Now we can equalize the denominators. Here we have 4. So you multiply this by 4, multiply this by 4. You get k plus 1 the whole squared, k squared plus 4k plus 4 whole by 4. And this we all know that this is k plus 2 the whole squared. So this is basically k plus 2 the whole squared by 4, and that's exactly what you require. It is k plus 1 into k plus 2 by 2 the whole squared, and that is our RHS. That's how pk plus 1 is true from steps 1 and 2. The given statement is true by principle of mathematical induction. That was our problem number 2, and this is how we solve a problem by principle of mathematical induction. Remaining questions we are taking it up in the next part. Thank you.